Hi everyone, just a quick video to talk to you through how to do searching algorithms in computer science. So in this video we're going to talk about the two main types of search being linear search and binary search. Now a linear search is as straightforward as it sounds. Basically all you do is you start from the left hand side, so the item on the far left, the first one, and you keep going down through each one of the items until you find what you're looking for. So for example, if I wanted to find llama, now there are multiple ways of showing this, then the best way I find is just to go, well, I'm currently looking at giraffe, so I put an arrow underneath it, write number 1, and say, well, this is the first item. Is this item equal to the item that I'm looking for? And the answer is obviously no. So I'm going to have to try the next item now and say, is this item the item I'm looking for? And obviously again, it isn't. And you continue on in this fashion through all of the items until you get to what you're looking for, which is indeed llama, and therefore we've found what we're looking for. Now at this point, you do stop the algorithm. There's no reason to go any further because you've found what you're looking for. Some people might ask, oh, what happens if there's another item later on the same list also called llama? The purpose of this algorithm is simply to find the first instance of where this item appears in the list. So that's all very well and good, but the problem with a linear search is it can take a very long time, especially if there's loads of items in the list. It can take as many items as there are in the list to find it. So rather than doing that, you can do something called a binary search instead. Now, a binary search, the only thing you need to do with a binary search is you need to make sure that the data is actually sorted into order before we do that. Now, I'm sure you've probably had a look at the sorting algorithms videos already. If you haven't, do have a little look at those. But for the sake of now, I'm just going to assume that they are in order and just sort of change them to be in order. If this was given to you as a question, you'd have to sort them into order before they work. Now, when you're doing a binary search, it's really important to break the list in half each time. So you start from the middle rather than the left-hand side. However, because there's 8 items in this list, what we need to do is actually go to the left-hand side. So the first item we're looking at is hippo, because that's the first item we're looking for. Now, in this instance, I'm going to look for tiger. So if I'm looking for tiger, that means that hippo is not equal to tiger. But we know that it's not just equal to it. We know that H is further down the alphabet. So it's earlier in the alphabet than is T for tiger. So that means that we know that hippo is not what we're looking for. But rather than wasting our time looking at other data we're not interested in, we already know that even though we don't know what these are, because a computer has to search for one name at a time, that means that we don't need to look at these items because we know that all of them have a letter that is less than H at the start. So without even looking at them, I know that these items are not what I'm looking for. So that leaves me with half of a list remaining. And again, what I do is I get my line, draw it in the middle, and now I go to the left, and the second item I'm looking for is llama. And again, llama is less than tiger. And the T is a bigger letter, well, further in the alphabet than L. So we don't need llama, and by extension, we don't need koala either. And again, break the list in half, go to the left if there's more, if there's 2 items, or an even number of items. Then shark is our third item we look at. Again, it is not tiger, it is less, so we remove it. And then we put our arrow underneath tiger. It's the only item that's left, and it's not a number, so we go straight to it, and this is what we're looking for. Again, if this was a larger list, then we'd look for the item itself, and we wouldn't look for any other more versions of the item. So as soon as we find it, we stop the algorithm at that point. So if you'd like to have a go now at the list at the top, you can see the list of 8 names just here. Take your time to work out the searching algorithm and have a go yourself. And pause the video and have a go straight after with the feedback. Okay, so the first thing we're going to do is perform a linear search on the data above. So a linear search means we go through the data one at a time until we find what we're looking for. In this instance, firstly, we look at Fred, because it's the start of the list. So this is the first item we're looking at. It says here to record how many names have had to be checked as well, and it's simply just the amount of arrows we've done. So we've done 1 arrow there. Rosie with the second. because neither of these are equal to Dave, are they? So those aren't it. So we don't want Fred, we don't want Rosie, and we don't want Alex because that's not equal either, or Pete, or Chloe. But there we have it. We found Dave, and again we found Dave, and therefore we don't even look at these items. Therefore, the amount of names we looked at is 6. Now, to do a binary search on this data, we actually have to sort it into order first. So let's just write this data in order before we even search for it. It's like searching through a dictionary. It wouldn't be possible to search through a dictionary if all of the actual the pages weren't in order, would it? So it's really important to make sure that all the things are in order before we actually start using a binary search to search through them all. Hopefully I don't miss any. You could just go around and making sure that we have all of the names in place by striking them off the top list, but looking like that's 1, 2, 3, 4, 5, 6, 7, 8 names, I think we're good. Right, same rules as before. Let's break this list in half. We start from the middle, but we go to the left-hand side. So the first name we're looking at here is Fred. Fred, we put a 1 underneath, so we know that that's what we've started looking at. We don't look at any of the names to the left-hand side or at Fred now, because Fred is further forward in the alphabet than is Tom. So we don't want to look at that. We therefore know we're not interested in any of these items either. So again, start from the middle, go to the left-hand side, and then Peter is our second item here, okay, that we're looking at. So we're not interested in Peter or Louise, sorry. Then we go again, break the list in half, go down to the left. Rosie is the third name we're looking at, which we're not interested in, so we remove Rosie, leaving us with only one item left, and that is Tom. And therefore we have looked at 4 names to find that many pieces of data. Well, we've looked at that many pieces of data to find what we're looking for even. So I hope this was helpful, bearing in mind that I've obviously gone for the items that are on the far right, but they don't always have to be on the far right, and I've only used names too. If you were using numbers, then obviously if I had numbers like 1, 3, 5, 6 and 7, for example, I would obviously start from the middle number to start with, so 5 would be the first number I'd check. If I wanted to look for 1, for example, 1 would be less than 5, so I'd start again, go for the middle to the left-hand side, and then number 1 would be the second number I would be looking for in this little list. These numbers are sorted in the same way. They're from lowest to highest, so ascending order. Same as you will have done in the previous sorting algorithm video. So it's exactly the same for numbers. It's exactly the same as it would be for letters and words too. Okay, exactly the same principle. Okay, hope this was helpful. Again, if you're not sure, please feel free to leave a comment down below and I'll answer any questions I can find.